Hello, my name is James Covington. I'm a professor in electronic engineering at the School of Engineering, University of Warwick. Today I'd like to present the electrical and electronic engineering and electronic engineering degree streams. Electronic and electrical engineering are professional engineering disciplines that are generally dealing with the study and application of electronics, telecommunications, and electrical power. Electronic engineering is more focused on electronics and telecommunications, whereas electrical engineering is more focused on electrical power. By referring to electronics, one considers the physics of electronic materials, semiconductors in particular, the basic devices such as diodes and transistors, electronic circuits such as amplifiers, and very large-scale integrated circuits. The use of electronic materials, the devices and circuit configurations, change as one goes from low power to high power applications, and from low frequencies to high frequencies, such as microwaves. Telecommunications, often referred to as just communications, considers the transmission, reception, and processing of signals. It should be noted that signals and signal processing can be found in the electrical power field too. Specialist fields of telecommunications include radio communications, optical communications, and information theory. By referring to electrical power, one considers the generation, distribution, and storage of electrical power. These latter areas include specialized topics such as electrical machines, transmission lines, smart power grids, and electrical devices. To collect data, process them, and optimize components, devices, and systems, electronic and electrical engineers use computer-aided design tools and embedded systems, such as microcontrollers, field programmable gate arrays. Hence, knowledge of CAD tools and programming of embedded digital systems is important. Electronic and electrical engineering has an impact on many aspects of our lives. It covers areas as diverse as smart, sustainable cities, the environment, clean energy, global warming, public transportation, energy efficiency, quality of education, food and agriculture, industry, innovation and infrastructure, life below the water, and even good health and well-being. Our degrees provide the skills, the experience and knowledge to work in any one of those fields. We offer a BEng or MEng in electronic engineering or electrical and electronic engineering. In both degrees, we also offer an intercalated year where you can have a year in research, you can study abroad, or have a work placement. For the MEng course, we also offer the opportunity to have an exchange year. The School of Engineering teaches many different disciplines of engineering. This is not only electrical and electronic engineering, but areas including biomedical systems, civils, automotive, mechanical and systems. Importantly, all of our engineers take a common first year and a common first term in the second year. This provides them with a good overall knowledge of all forms of engineering. Those with a particular interest in electronic engineering or electrical and electronic engineering will do in their first year electrical and electronic circuits, engineering design, engineering mathematics, and materials for engineering which are particularly relevant to their interests. But they will also be taught modules to broaden their horizons, such as professionalism and practice. Those students who decide to take the electrical and electronic engineering course will then do 3 further core modules in the second year. These are analog electronic design, semiconductor materials and devices, computer architectures and systems. These modules are also common with electronic engineering course. Students will then take 1 further module from a range of optional modules. In the third year, they will do an individual project, and 4 modules also common with the electronic engineering course. These are power electronics, communication systems, digital systems design, and signal processing. They will then take 2 further modules, which are just for the electrical and electronic engineering students. These are power systems and electrical machines, and systems modeling and control systems. In the 4th year, there is a group project and 2 modules also common with electronic engineering course. These are advanced power electronic converters and devices and ASICs, MEMS and smart devices. They will then take 2 further modules only for electrical and electronic engineering students. These are operations and control of power systems and control of electrical drives. They will then have the opportunity to take 2 optional modules. The ones listed here are examples from previous years. Those students who choose to take the electronic engineering course will do the same second year as the electrical and electronic engineering students, formed of 3 core modules and 1 further module from a list of options. In the third year, they will do an individual project, and then 4 further modules common with the electrical and electronic engineering course. They will then take 2 modules that are designed just for electronic engineers. These are Fundamentals of Modern VLSI, Microwave Engineering and RF Circuits. In the 4th year, they will take a group project and 2 further modules common with the electrical and electronic engineering course. Then they will take 2 modules designed only for the electronic engineering course. These are Radio Wave Propagation and Wireless Communications Theory and High Performance Embedded Systems. They will then choose 2 further optional modules. Here are just 2 examples from previous years. In the 3rd year, all engineering students undertake an individual project. These projects run through Term 1 and Term 2 and are worth 25% of their 3rd year mark. There are many hundreds of projects available, and this provides the opportunity for students to follow their own interests. They can even propose their own projects. Listed are example projects from previous years. For electrical and electronic engineering students, there have been projects in testing silicon carbide diodes, in developing inverters for renewable energy, and for undertaking thermal testing of power semiconductor devices. For electronic engineering students, there have been projects in wireless sensors, in optical wireless chargers, in drones, electronic noses, electronic tongues, and a number of other projects where students have the opportunity to design and build electronic circuits and systems. Academics also offer projects in the machine learning and AI area, with machine learning for communication receivers as a good example. In the 4th year, all MEng students undertake a group project. In these projects, a team of engineers from different disciplines are brought together to solve a real-world problem. Here is a list of example projects from the 2019-20 academic year. And on the right, pictures from this year and previous year projects. In the top right is the human-powered submarine, who competed in the international submarine races in Maryland, USA, winning an award for the Smooth Operator. This submarine contains a number of electrical and electronic systems to monitor the progress of the submarine. On the bottom right is an example from the Warwick mobile robotics team. Here they are researching and developing an urban search and rescue robot. In the middle are photographs from the WooSat satellite team. The WooSat group project has run from 2006 and is sponsored by ESA. In 2015, the WooSat team designed a CubeSat which was launched in Sweden on an Orion rocket. WooSat 3 is being designed to track wildlife. It will be launched into low Earth orbit from the International Space Station. Warwick is the only university in Europe whose team is formed of undergraduate students. The WooSat project team have worked with over 40 companies, either through sponsorship or partnership. In fact, many projects have industrial partners who support the team through resources and training. These projects produce skills that are extremely attractive to employers. There is a wide range of areas in which electronic and electronic engineers can work. This include medical instruments, the energy sector, mobile phones, aerospace, nanotechnology, satellites, robotics, automotive, test and measurement, domestic and industrial appliances, education, structural and health monitoring, toys and games, naval engineering, security, oil and gas, CAD, broadcasting, IT consultancy, special effects, systems analysis, technical sales, photonics, microelectronics, IoT, banking, acoustic and defence, and this is to name but a few. I hope you've enjoyed your presentation today, and I hope it's provided you with a useful overview of our degree stream. Thank you.